Since we now have improved the visual, let's go ahead and start coding our character controller. So for that, I'm going to go under MicroLand, open that up, double click, and I am going to create a new asset group that I'm going to call scripts. With script selected, I am going to go under asset, new script that I'm going to call character controller, and I'm going to select that by default on update function callback and a on gamepad access function callback will be created, since I'm going to use a game controller to actually code my character controller. With that said, I'm going to go under properties and application, and I'm going to create a new thread here, and I'm going to drag and drop my character controller. The reason why I'm dragging and dropping this character controller inside the application script is because the application is the one that is responsible for the input coming from the keyboard, the mouse, a touchscreen, or a game controller. And why I'm using a game controller for this specific tutorial, it's because it's the easiest that can be either converted to a keyboard mouse combination or a touchscreen combination movement. So if you want to have more information about how to implement a keyboard and mouse or touchscreen, have a look. I'm going to jump over the coding layout here and have a look under lib, scripts, and controller. Here you're going to find the sandbox controller script, and inside that you have access to how to handle properly a keyboard event and as well as mouse and touchscreen event. You can see here based on the platform if it's iOS or Android, switch to a touch-based mechanism or simply use a mouse mechanism. You are going to have all the code that is necessary to do that here to be able to convert our character controller into a mouse keyboard movement or touchscreen movement. So we are going to jump now under MicroLand and scripts, and I'm going to select my character controller. And to get started, I'm going to declare a few variables. I am going to declare the following. For the direction, what direction my character is actually moving towards to, I'm going to have its actual rotation that will be contained here. I am going to declare the maximum walk speed of my character and how high he can actually jump. Now I need to have access to my character and character controller object, which are part of my scene. So I am going to declare the following. I am going to grab the first scene that is currently loaded, in our case here, our MicroLand, and I am going to get the character object and get the character controller object. Next, I'm going to jump over to the on gamepad access function callback, and I am going to now grab the code to implement that when I move left and right, my left and right on my left analog stick, I will be controlling the direction X, and up and down on my left analog stick, the direction Y. So what I'm going to say is if the absolute value of my axis 0, which is my left analog stick, left and right axis, if it's greater than 0.05, give a little threshold to ensure that the user is actually pushing that direction. Assign the value of the axis 0. Instead, simply set 0 the direction X. For the direction Y, same process. Check if the axis 1, in my case, up and down on my left analog stick, is greater than 0.5. Assign the axis 1 to direction Y. And in my case, I have to actually invert it. If you see later on that when you push up on your game controller, it's going down and down is going up, just invert that, remove the negation here to have the proper up and down movement, which might vary from game controller to game controller. Next, I am going to go on my function on update, and I am going to paste the following code to actually control my character controller here. So if the direction X is different than 0 or my direction Y is different than 0, I am going to set a friction of 0 to my capsule. And the reason why I'm doing this is, let's imagine for a second, since our character can jump, let's imagine for a second that I'm located like somewhere like right here, and I jump and I push forward at the same time. What is going to happen if I set a friction of a static value? I am probably going to just just stick on the wall there, as it's going to clash with the actual gravity. So using this approach, there's multiple ways to go about it. I tried to go with the most simple approach for this tutorial. So the way we're going to proceed is like this. As soon as we have a direction, a movement, we're going to set the friction to 0. So basically our capsule will be like walking on ice. There's no friction or no resistance whatsoever. And as soon as we release the movement, we're going to set a friction of 1, which would make our capsule stay straight. It will not continue to slide. And next, I'm going to use the linear velocity, and I'm going to say that my direction X is multiplied by my maximum walk speed. I'm going to repeat the process for the Y velocity, my direction Y, multiplied by my walk speed. And I'm going to use the normalized angle, that normalized direction vector, to calculate, to extract using pure trigonometry, the Euler angle Z, which will make my character look straight in the direction where I am heading. So I'm going to store this into rotation, and I am now going to affect the rotation to my character basis matrix here, just like that. I am going to set the rotation of my basis matrix to be my current rotation. And if you recall, in the previous step, we have implemented a constraint on our character to spherically interpolate our rotation. So it will kick in, and like that, we're going to have a smooth transition up to down, down to up, left to right, instead of having just a single switch from one direction to another. I am now going to build and save this script, and I'm going to push play here to increase the application time, and I'm simply going to test my left analog stick right now, and it seems to work well. Now the next step, I am going to pull a timeline and increase the physics step as well by clicking this button here, which increase the physics time step. And now my character is going to not only be able to turn, he's going to be able to move in space. Now the last bit that we want to implement is, if our little guy fall down, we want to reset him back to our flag here. So what we're going to do, we're going to add something else into our onUpdate function, and we are going to compare the linear z velocity. So if our little guy is falling, the linear z velocity will start increasing. So at the top here, I am going to check if the velocity is greater than half of the gravity that we set up on our capsule earlier. So I am normalizing the flow to don't end up dealing with too many dots after, too many zero after the dots. So I'm going to round that up to 2 digit after the dot, and I'm going to check if it's greater than my gravity. If the normalized flow is less than half of my gravity, I am simply going to reset, because I'm going negative. Okay, so this is why I'm using the less, and I'm going to reset back the transformation, and that should bring him back straight to our starting flag here. So I'm going to build and save that, and I'm going to go try to kill myself by bringing our little guy here. And then if he start falling too fast, he's going to simply reset back to the flag itself, just like that. And next, we are going to implement a jump functionality, and we're going to start moving on from there, implementing also better camera movements. Let's now go ahead and implement jump functionality. The first thing that I'm going to do is I'm going to create a new variable that I'm going to call on ground, which is going to hold a Boolean value that is going to be either true or false if we are on the ground, which leads me to now implement a new function that I'm going to call ground check. And ground check will go through all the contact point of our capsule and check if we have a normal z greater than 0.85. When we're straight on the ground, the normal z will be 1. So by tilting it a little, let's say 0.85, when we are on a slope in the mid section of the slope here, we will still have a valid ground check. And the reason why we are using the absolute value, since our guy can now jump and can basically fall down from relatively quite high, it might happen that for a split second we are penetrating the collision map, and the normal z will then be inverted. So by using an absolute value, we ensure that we're always going to return a true if we are on the ground or not. So next on my onUpdate function, I am going to assign to my onGround function the ground check. So onGround equal to ground check, the result of my function. And next, I am going to go at the end of the file and implement a new function callback that I am going to paste right there. That is going to be on gamepad buttons. What this does is checking the current game controller button mask and check if, using a simple bit check, if we have the first button of my gamepad pressed. If it is actually pressed, I am going to check two things. First, am I on the ground? If yes, I can jump. And the direction 0 is equal to 0. What I'm going to implement is sort of a cycle. So if I have, if I'm on the ground and my direction Z, that is going to tell me if I'm jumping or not, is 0, then I'm going to set that the direction Z is equal to 1, which will give me the go to jump. And up here, I am now going to implement that. I'm going to move that direction Z from 1. If it is 1, start jumping, then move it to 2. So like that, I am going to, if all that fail, I'm going to end up back to 0. So like that, I want to avoid that the user keep pushing the jump button over and over. I'm going to create a cycle from 0 to 1 to 2 back to 0. So as soon as he release the button, I go back to a true 0, which will give me the opportunity to jump again. And to finalize this cycle, I'm going to go back in my onUpdate function here, and I'm going to modify my condition over here. So what I'm going to do is I am now going to paste this code here to first check if I am jumping, if the direction Z is equal to 1, assign to the linear velocity Z our max jump height here, and switch my direction to 2. And also don't forget to set the friction to 0. So like that, like I was explaining earlier, I will not just stick on the wall here. And I'm going to modify this condition to be now else if, moving on to my direction. And finally, I will add that the else will now be else if I'm on the ground, I will set the friction to 1. So if I'm jumping and in the air, set the friction to 0. If I am actually moving or moving in the air, my friction will be 0. And if I have a valid ground check, I am going to now set my object friction back to 1 to stop the motion of my character. So we basically now have jump functionality implemented. I am going to build and save, make sure that my application time is actually running, and ensure that in my timeline, I am also increasing the physics time step. And now as I pick up my game controller and start going around, as I push my first button, I am now able to jump, and I can now go through my level. If I jump and kill myself, go back to the beginning. And now we are going to implement better camera control because the camera is a bit stiff at the moment. We are going to remedy to that situation in a moment. Okay, let's now improve our current camera system. The kind of camera that I'm looking for to implement is basically a camera that have a 3 position on the left and the right and up and down, which means that if I push my right analog stick on the right, I'm going to move my camera this direction, still looking at my character. And if I push it back on the left, it's going to reset back to the center. Left again is going to move on the left side. So depending on where my character is heading and based on the level layout, I will always find a good direction to look at. And I'm going to implement the same thing for up and down to have a top view, middle view, and bottom view. Basically 3 position on the left and the right, as well as up and down, to always find a good angle for our camera to look at while moving through the level. So basically what I'm going to do is first I'm going to get access to my camera from the script, the character controller script, and I am going to get access to my camera, which is geometry. And if you recall, we have implemented an elliptic constraint under that camera. And what I'm going to do is, based on the user input, I'm simply going to change that angle X and angle Z to be one of those three positions, either left and right or up and down. So I'm going to need to have access to my elliptic constraint here that I'm going to store into the CST variable. And next, I'm going to declare a few more variables to have access to my current and my next angle. What we're going to do is we're going to linearly interpolate from one position to the other progressively. So I am going to declare that, and I'm also going to declare a new function that I'm going to call lerp, which basically simply linearly interpolate a float value. Another thing that I don't want to happen is if my user is just simply holding a specific direction, that my camera like drastically move from right to left or left to right, up to down, down to up. So what I'm going to do is I'm going to declare another variable that is going to hold the current time in millisecond. And if the user input time is too short, I am going to simply ignore the signal. Instead, I'm going to process it. So with that said, I'm going to go down and I am going to go under my on gamepad axis, and I am going to implement the current code. So we keep our directional code intact, and we're just simply going to paste the following. So grab the current application milli time when the gamepad axis is pressed. If that time is less than 500 millisecond, we are going to simply ignore the signal. And then the same way that we did with our direction left and right up for our character movement, we are going to check if we got a absolute value coming from our x-axis greater than 0.5 this time. We want to have like we want to analyze if the user input a drastic movement on the left, on the right, up or down. So here we were looking for, more precision. Here we're looking at a large movement, more than halfway, and then we are going to modify that angle. So if we are moving the right analog stick left to right, we are going to change the angle Z, and we're going to clamp that angle Z to be plus 35 from the range of where we get started at 180. So minus 35 will bring us at 145 plus 35, 215. And we are going to store our current time in the sync so we can repeat that same check over and over again. We're going to do the same thing for our up and down axis, which this time will modify the X angle. So this time not go as drastic at 35 degrees. Let's go like somewhere around 15. So we are starting at minus 45, which is our top value. And we are going to now be able to go down one level that is going to bring us at 30, and from 30 minus 15. And once again, store the current time to the sync. So I'm going to push play, and I'm going to ensure that my application time is running. And the last bit of information that I need to do is actually interpolate this angle that we're going to modify and assign them to my elliptic constraint. So under the onUpdate function, I'm going to paste the following code that is going to linearly interpolate between our next angle X with the current angle X. And we are going to smooth things down by having our application delta time multiplied by 10. Repeat the same process for the angle Z. And after that, assign to our constraint the current angle Z that we have computed, the next angle Z, angle X, and for the angle Z, the next angle Z. Like that, we're going to have a smooth movement from left to right and up and down. If I build and save that, now I pick up my gamepad, and as I push down, I can see that I'm moving from one of these three positions. Same thing on the right, go back to the middle and the left. And like that, as I go, I can simply change and tilt my direction to ensure that my camera will always look at my character, and I have a better view of the actual level as I go in. It is not as flexible as a full third-person camera that can look 360 degree. But for the kind of game that we're building right now, it is basically appropriate. Let's move on and now start adding movement actions to our little character.